A certain experimental mathematics program was tried out in two classes in each of 32 elementary schools and involved 37 teachers. Okay, two classes in each of 32 different schools. So that means the total number of classes is 2 times 32 equals 64 total classes. Total classes. And in that sentence, we also learned that there are 37 total teachers responsible for those 64 classes. All right, where do we go from here? Each of the classes had one teacher. Okay, so everybody gets a teacher. And each of the teachers taught at least one, but no more than 3 of the classes. At least one, but no more than 3. I guess that means that all of these teachers are either teaching 1, 2, or 3 classes. So that 37 is broken down such that some of those guys, some of them are teaching 1 class, and some of them are teaching 2 classes, and some teach 3 classes. That's the only way we can have at least 1, but no more than 3. Although I guess it never says it has to be a positive number. It could be 0 teaching 1 and the others, but nobody's teaching 0 classes, and nobody's teaching 4 classes. All right, what else do we get? What are they asking? If the number of teachers who taught 3 classes is n, so we're given a variable for how many teach the 3. So I'm not just arbitrarily saying some. I'll say n of our 37 teach 3. Then the least and greatest possible values of n respectively are. All right, we are asked for the minimum and the maximum value of the number of teachers teaching 3 classes, and I guess already we should be prepared for applying some minimizing, maximizing logic at some point. It's really always the key on these min-max questions. All right, so we've got our information organized. If we're going to use algebra, I guess we're going to want to get some equations. And if we're going to get some equations, I guess we're going to want some variables. So we said that n of those teachers teach 3 classes. Let's get a variable for the number of teachers teaching 1 class. Not some, but let's say x of the teachers teach 1 class, and let's say y of the teachers teach 2 classes. Okay, so equations. Well, what's really nice about the info we got early on is we got a couple of totals. Total number of classes and total number of teachers. And I say that's nice because we can almost always build equations out of totals. So let's see if we can build an equation out of our total number of classes. Total number of classes is 64. And that is going to come from the classes that are taught by teachers only teaching 1 class, and the classes involved over here by the 2 class teachers, and the classes involved over here by the 3 class teachers. So let's see. If we're talking about classes, x of the teachers teach 1, so the number of classes is just going to be, well, x teachers times 1 class each, or 1x, or just x. And if we're talking about the 2 class teachers, well, we've got y teachers each teaching 2. That means the classes involved will be y times 2, or 2y. And the classes involved here for the 3 class teachers will be 3n. Okay, what about our other total? Can we get an equation with this 37? And we certainly can. That 37, well, that's just the total number of teachers. That's the 1 class teachers plus the 2 class teachers plus the 3 class teachers, or x plus y plus n. And now we've got 2 nice equations nicely lined up, and I like that they're lined up because now we can see that if we subtract our second equation from the first one, we're actually going to get rid of a variable since the coefficient for the x's is the same. So if we subtract this whole second equation from the first, what do we get? Let's see. X minus x is 0. The x's are gone. 2y minus y is just y. 3n minus n is 2n. And 64 minus 37 is 27. And that's a much better equation. We're getting a lot closer to something that we can apply some logic to. Although, what is the variable that we ultimately want to apply logic to? Well, ultimately, we want to make some deductions about n. So I'd say we can make this even easier if we isolate n. So, taking y away from both sides, we get 2n equals 27 minus y. And then dividing both sides by 2, we get n equals 27 minus y over 2. And this is much better because, well, now we've got an expression for the thing we are trying to make deductions about. So, well, let's think about that thing. We're trying to minimize or maximize n. And I guess let's start by trying to maximize it. So if we're trying to make n as big as possible, and I'll say that this is one of the most important takeaways from this question, that if you're trying to minimize or maximize one thing, you're almost always minimizing or maximizing something else. If we're trying to make n as big as possible, well, what do we want to do to y? Let's think about it. If we want n, this whole thing, to be big, I guess we want this numerator to be as big as possible, which means we want to take away as little as possible from that 27. In other words, to maximize n, we want to minimize y. So let's think about this. If we're trying to find the maximum possible value of n, well, we said if n is going to be as big as possible, we want y to be as little as possible. So let's just see if it works if we call y 0. If y is 0, then what does n become? N becomes, well, we can just use this. N becomes 27 minus 0 over 2. And that is just 27 over 2, which is 13.5, which is not great because it doesn't really make any sense to have, well, what does n represent? N is the number of teachers teaching 3 classes, and it doesn't make sense to have 13 and a half teachers. So this did not work for finding our maximum n. Well, we tried a y of 0. That was taking away as little as we possibly could, and it didn't work. Well, let's see if we can go with the next best thing. Let's say y equals 1. All right, if y equals 1, then n equals 27 minus 1 over 2, or 26 over 2, or 13, and that is much better. It makes sense to have 13 teachers. And actually, I guess we've done it. We have found our maximum value of n. If you want to make sure that x doesn't become a fraction or anything, you certainly can. We can say, okay, if y is 1 and n is 13, that means we've got our 13 teachers here and our 1 teacher here. And then to get to our total 37, we've got 13 plus 1 is 14, plus, let's see, 37 minus 14 is 23 for x. And yeah, that is certainly not a fraction. In fact, we didn't even need to do that. We could have just said, well, this is an integer and this is an integer, so we're going to add an integer to this, so we're not going to end up in any weird scenario where we've got half a teacher. So I guess we've done it. We have found that our maximum possible value of n is 13, and what's really nice is that only shows up in one answer choice. So we click A and get our points.